This is the homework video for Worksheet H4-4. This is problem number 2. We have y equals x squared, and we have x squared plus y squared equals 12. So if we think about what these functions are looking like here, we have, it looks like a parabola, right? This is like our parent graph for a quadratic function there. So we're going to have a parabola that opens up. And then x squared plus y squared. Anytime you see x squared and y squared in there right now, okay, typically we're going to be looking at a circle, okay? Could be an ellipse, but we haven't really talked much about what those are yet, so just kind of think about it as a closed figure like that. So we talked about this one in the notes a little bit, right? We could use some simple substitution here. Now what I've seen in class here is people will take, since y equals x squared, they've been plugging in x squared plus and x squared squared equals 12, which can be done. We know how to factor and solve that there, but I think it's probably going to be easier here on this one if we take a look at the fact that there's an x squared in both of these, right? So since x squared is already by itself, we can say that that x squared actually is equal to y, and we can substitute that in. So actually we'll do that one over here. And maybe I'll do the other one here just so everybody can see both methods there. So if I'm going to take this out, and I'm going to replace it with my y. So here we go. We've got y plus y squared is equal to 12. And, if we look at that closely, we've got a quadratic. I'm going to just rewrite it here. I have y squared plus y, and we'll subtract the 12 from each side. And now we can factor it here. That's going to give us a y plus 4 and a y minus 3 inside the parentheses. And then we're going to take those and set them equal to 0 and solve it. So y is equal to negative 4, and y is going to end up equaling 3. I didn't write my equals 0 there, but that's fine. You know what I'm doing here. So right now we've got those two values. Remember, those aren't our final solutions, though. Our final solution should be points, because these are systems and contain x's and y's. So we need to figure out what those x values are going to be. Now you can take these values and plug it back into either of the functions. I'm going to plug it into the first one here just because there's less going on in there. If I take my value of negative 4, right, I'm going to plug it in for y. I have negative 4 is equal to x squared. Well, already we can kind of hold up and stop here because we can't really square a number and end up with a negative right now. I told you later in the year we'll work on that there. There is some more options later in the year, but right now we can go ahead here and say that that's not going to work. So our second answer that we got here, y equals 3, let's take that one and plug that one in. So as we do that, we're going to have 3 is equal to x squared, which makes a little bit more sense, right? So when we take the square root of something squared, we will get that positive. So we're going to take the square root of each side, and after we do that, we know that we're going to end up with the absolute value of x equals the square root of 3. So therefore, x is going to have to equal positive or negative square root of 3. That's two different answers. That means when y is 3, if we think about our points, when y is 3, we could have a positive square root of 3 for x, or we could have a negative square root of 3 for x. So it looks like here that there are going to be two answers. So I can show you how to graph that in class if you want to see it. Now, before I leave this problem, I kind of want to show you the second method here for doing it here. We've got, we'll just call this method 1. I think this is probably the easier method. But if you do remember what we did with equivalent forms, we can do method number 2 over here. So when I take x squared and squared, I'm going to get an x to the 4th power, right? So I have x squared plus x to the 4th equals 12. And then when we take this here, let's just rewrite it so it's in more of a standard form. We have x to the 4th plus x squared, and I'm going to go ahead and move my 12 over here so it is a trinomial. We've got two powers, a 4 and a 2, and you notice that our middle term, that middle power, is half of the first power, which means it's in a quadratic form, and we can actually end up factoring this. Remember, this is the same thing as saying x squared squared plus x squared to the first power minus 12 equals 0. So we can factor this into two binomials. We'll have an x squared in the front of each of them. And then obviously we're going to end up with a plus 4 and a minus 3. And as we do that there, we'll set each of those equal to 0. And I hope you start to see the similarities between where we're at in this process versus the process over here for the first method. Right, we get the x squared is equal to negative 4, which we know isn't going to work for us. And then we get the x squared is equal to 3, and which leads us to that x is equal to positive or negative square root of 3, which is the same thing we got on the other side. So we actually can do this. You know, we've talked about this in the past here. When we get it to this form, this is factorable. So you could actually do that. But if you're not comfortable with it, then go ahead and jump into method 1. So your solutions for problem number 2 is radical 3, comma 3, and negative radical 3, comma 3. If you have questions, please make sure you ask about them in class.